Today we're going to be doing Chapter 8, Section 1 about three-dimensional figures. The essential question is how can you draw three-dimensional figures, and we will be getting to that as we go through the chapter here. Certain vocabulary that you need to know within this chapter is to understand what a solid is. When you hear the word solid, it's referring to a three-dimensional figure, and three-dimensional you can also think as 3D, three-dimensional figure that encloses a space. So any three-dimensional figure that is boxed or closed in. Okay, no open spaces. You're going to hear the word polyhedron. Okay, a polyhedron is a solid whose faces are all polygons. And if you forgot what a polygon is, it's a figure with at least 3 straight sides and angles. Typically they're 5 or more, but that would have sides like triangle, quadrilateral, pentagon, hexagon, things like that. Face is another one that you're going to hear, and that is a flat surface of a polyhedron. So that is just going to be those shapes, the flat shapes that you see that make up a 3D shape. Okay. One of the other vocabulary words you're going to see is edge. Okay. An edge of a shape is a line segment where two faces intersect. Okay, so that's where like right over here, here's your model over here, your little picture to help you understand. Face, that's like where the X is. That's the rectangle here. There's a face here, there's a face on the top, there's a face on the side, there's a face on the bottom and the back on this other side. The edge is this line right here where the front and the bottom meet, or the side and the front meet right there. That's the edge. And a vertex is a point where 3 or more edges intersect. So like right here, there's another vertex there, there's another one there. And if you hear the plural with more than one vertex, it's referred to as vertices. So if you see that word, that's what that means. Okay, we're also going to be hearing the word prism quite a bit. A prism is a polyhedron that has 2 parallel identical bases, and the lateral faces are parallelograms. Okay, so the other sides of a prism are parallelograms. You also are going to be working with pyramids, and this is a polyhedron that only has 1 base, and the lateral faces around it are triangles. They're always triangles. Okay, and these are always parallelograms for the other faces around the bases. Okay, and just a little hint to remember that the shape of the base tells the name of the prism or the pyramid. And we'll get into that in a minute, but you need to find your base, you need to see what shape it is, because that's going to help describe your prism or your pyramid. So here we have that situation where we are going to name that shape. So over here, I'm seeing that we have an identical face here to this one over here. Okay, those are our 2 bases. Because it has 2, it shows us that that's a prism. Remember, they have to have identical parallel bases, and there has to be 2 of them, so they're right there. They are triangles. That's the shape. So the name of the shape would be a triangular prism. Now over here I'm noticing that this shape has no identical parallel faces. Okay, there's only 1 base. The rest, all the shapes around it, all the faces are triangles. That helps me know that this is going to be a pyramid. Okay, and the bottom here is a rectangle. The base is a rectangle, not just the bottom, because bases aren't always at the bottom. But the base is a rectangle, so this would be a rectangular pyramid. Okay, so the first thing you really want to do is look for what might qualify as a base in your shape to see if it's a prism or a pyramid, and then what shape it is to help name the three-dimensional shape. Okay, to draw a rectangular prism, you have 3 different steps you're going to follow. The first step is to draw identical rectangle bases. So you start with 1, and then you go up above it, kind of in the middle up high, and you start to do your other rectangle there. So bottom one, and then one up over above it to the right. Then you're going to connect the corresponding vertices. So that means your top left vertex is going to have a line with your back top left vertex, okay? Your bottom one here is going to connect with your bottom one there. Your top one here with your top one there, and your bottom one here with the bottom one there, okay? Then the next step, I'm not going to do it because it's hard to erase on here, but you can change any hidden lines to dashed lines. So like if this was actually a real solid in real life, okay, like looking up here, you wouldn't be able to see through this face to see this line or this line over here, okay, or the back here, because that would mean that you have like x-ray vision. You'd be able to see through this, which we can't, but we know those edges are there, which is why regularly in drawn shapes they're dotted. To do a triangular pyramid, so that means the base is a triangle, you're going to draw your triangle, and then you put a point above that top vertex there, and then all you have to do is draw a line to each, from the point to each one of the vertices. Sorry, it's really hard to draw a straight line on here. And then again, any hidden lines you would go ahead and show as dotted lines from there. One of the other tasks you'll be asked to do with three-dimensional shapes is to be able to identify and draw the front of the shape, the side of the shape, and the top view of the shape. So we have two solids here. We have a triangular prism and a rectangular pyramid. So we're going to focus on this one first. The front, that's this piece right here that you're looking at. So that is a triangle shape. The side, that's over here. Okay, that's a rectangle. The tricky part here is the top. So you're looking at it from up above, right here, like right at this edge. If you're going to squash this edge down, you're going to push it down to the floor there, push it down to the ground, what would this shape look like? How would it spread out? So if you push this down, okay, this side is going to flatten out to the right, and its opposite side over here on the left, that's just like this, is going to flatten out over to the left. So you're actually going to have two rectangles that are flattened out. Here's that top edge, and you flatten it out. This side, whoop, swoops out there, and the other side, whoop, swoops out over to that side. Front, here we go. We've got a rectangular pyramid here. Your front is a triangle. Your side, that's another triangle. Lots of triangles and pyramids. The only thing that might not be a triangle is the base. Could be a triangle, but in this case, it's a rectangle, okay? But we're not looking at the base right now. We are looking from above to look at the top. If we were going to squish this point right here down to the ground, how would those faces that come off of it, how would they branch out? Okay, well, you're going to have, this is going to be 1, 2, 3, 4. There's 4 faces around the sides, and that makes sense because they shoot off of a rectangle which has 4 sides. So we're going to need 4 triangles. So when you flatten it out, it's really going to look like this, like a smushed, the smushed pyramid is going to have all of the different faces here pressed out, okay, with the point there flattened down. Okay, one of the other things that you're going to be asked to do is to draw the front, side, and top views of stacked cubes. Now this can be really difficult if you have difficulty with sort of spatial awareness with things, because it's kind of hard. It is kind of hard to see. But what you want to do is you want to look at the front first there. So over here, if we're looking at this stack, okay, and see kind of how it forms. Right, there's 3 that go down, and there's 2 rows of 3. Okay, so we're gonna see that. So we've got 2 of the rows, 2 rows of 3. And then we have 2 more, I shouldn't say rows, they're 2 columns, sorry, 2 columns of 3. Then we have 2 more columns over here that just have 2. So the front that we're looking at would look along the lines of that. This is where it gets a little tricky. If we're looking at the side over here, and we were looking at it from like this direction, we've got 2 cubes there, And then there's one more over there. If we had backed up like 100 feet and we're looking at this, there's no way that you're going to be able to tell with depth perception that this is farther back than this line right here. This is going to look like it is just lined up over here. And that's what we're going to draw. So you basically want to pretend that you're pretty far away and you don't need your depth perception. You're just seeing how many are stacked up in that line. You don't need to know which ones are farther back, which ones are farther forward. It's just how many are there in that area. So we've got 1, 2, 3. Okay. Now the top, same idea. Okay, we're looking at it from here. We've got 1, 2 there, and then we've got 2 that are farther back, but it doesn't matter that they're farther down or farther back. Okay, what matters to us is that there's 4 in a row there. And they're going like that in that direction. Okay, so we're all there. Now if we were going to count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 of them. Okay, this gets a little trickier when there are things like this one in example number 9, and we've got one that's on top of another one that's hidden but beneath it that you can't see. You don't want to forget to count that cube that this is lying on top of. Okay, over here with example 8, front, we've got 1, 2, 3, 4, 5. 1, 2, 3 in 1. So you're just really just drawing it how you see it. Right there. Side over here, looking at it from this direction, we've got 1, 2, 3 that we see. All stacking up. Again, doesn't matter if they're pushed back or pushed forward. There's 3 of them that go up. And then top, looking at it from down here, we've got this one here. Okay, that would be our like middle. Then we've got 1 to the right and 1 to the left. Okay, and then 1 more to the right and 1 more to the left. Because remember, again, it doesn't matter if they're lower down, if they're pushed back. You just want to see how many are in a row, whether you're looking at it this way or looking at it up down, like how many are in a column. Okay, number of cubes, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, over here, front. Okay, so we're looking at it from this direction. There's 2 to the left. There's 1 in the middle. There's 2 more to the right of it. So we've got 5 in total along this bottom kind of stack here. Okay, and then there's 1 more on top in the middle, like that. So if we're looking at it this direction, all of these would be in a line, and then 1 on top. The side view over here, okay, a little different because we're starting up here. We've got 1, 2, 3, 4 that are in a line here. Yes, there's this, but you can't see that from the side because this one's blocking it. 1, 2, 3, 4. Okay, so let me see here. 1, 2, 3, 4. Okay, and then there's 1 more on top, but this one you can't see that it's necessarily in the middle. You would just see that it's over. You remember, if you're that 100 feet away, you can't see how far back it is. It'll be over there. And then the top, looking down from above, you'd see this whole line right here, and then the 2 to the left of it and the 2 to the right of it. So you'd have a long line here of 1, 2, 3, 4. Because remember, you can't see the one underneath it. And then 2 to the left and 2 to the right. And how many cubes there are? There's 1, 2, 3, 4, 5, 6, 7, 8, and then the one underneath it that's pushing it up to stand it up there would be your 9th one. Okay. And the last thing that we're going to do over here, and this is going to go on to the next video as well too, but I'll read the directions here. You're going to be finding the number of faces, edges, and vertices of each one of these solids. So you're going to look at all of the shapes that make it up. Those are the faces. All of the edges, which are all of the straight lines. Don't forget the hidden ones there, the dotted lines. And then the vertices are all of the corners that we're going to be focusing on. Okay, so I'm going to pause here with the video because this particular video will run out of time, and I will put this on part 2.